Okay, Calculus Week 2. This, for a lot of you, will be your easiest week yet. The only thing I found is there's some things that need to be memorized that no one ever seems to have memorized when they get to calculus, and they show up all the time. Now, I'm not just talking about logarithms here. I mean, yes, this has a lot to do with good old-fashioned, log, but let me tell you, natural log is way more important. And of course e to the x. So what is their relationship? Well, it is good to know that they are inverse. They have an inverse relationship to one another, and in fact, if you want to think back to graphs, the graph of e to the x, let's say, looked something like this, and the graph of the natural log of x looked something like this, and you may be thinking, well, why is that important? Well, this is to show that inverse relationship. If you take all these x's and y's and then switch them, which is what inverse means, right? xy becomes yx, then you're going to get this graph instead. You may have had a teacher along the way that even showed you that an inverse relationship is such that if you reflect a graph across the line y equals x, it will in fact equal the other. And that's what makes these things go together. Now, what is the purpose? Why do we care about logs and natural logs and things like that? It's to help you solve a problem. Like, for instance, let me just do something basic first. Like if I said 2 to the x power equals 8. Okay, that's easy to just look at it and go, oh, well, x is 3. It's just 2 to the third equals 8. But if I say like 2 to the x equals 18, well, that's a little harder because it's going to be some kind of a decimal. And you'll remember from pre-cal and algebra and all that, this is where you would use logs to rearrange this problem, and it would look something like that. And then you would be able to get a calculation for this, like just pick up the calculator and type it in. Okay, that's what that is used for. Now, natural log, on the other hand, is the same idea as this, except for it being 2 to the x equals 8, or 2 to the x is 18, it would be 2.718 blah 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 to the x equals 18, or in other words, e, that is the same number as e to the x is 18. And so e is that magical number, very irrational, but also very amazing and important number in mathematics. And if you want to solve this, instead of doing, I guess you could rearrange it like this, where you could do log base e of 18 is x, but log base e of 18 is the same thing as the natural log. Like, this number is so important that its inverse got its own name as well. So then you just type that in the calculator instead of all that mess, and you would get your answer. Okay, so what's so important about it for calculus? Well, not just solving like you just saw up here, but there are things like when you're in the middle of your math, where I see this all the time. We end up with the natural log of 1 and blah 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 equals blah blah blah. This will end up in the middle of a problem, and I have students that freeze and they're like, I don't know what the natural log of 1 is. Yes, you do. I'm telling you, you do. You just don't remember. It is 0, and that is so stinking important I can't even tell you. It's going to show up all the time. So this is the number one property that you need to know. Natural log of 1 is 0. Another one might be the natural log of e is e. That's important to know. And then the other properties that you'll be using a lot would be the same things that were true for logs. We're just going to do them strictly with natural logs, okay? So in other words, like, okay, like let's say that you have, I'm going to do like maybe 3 different rules here, okay? So if you have something like the natural log of 3 to, and then maybe you have like a 1/2 out here, or something like that, and maybe there's an x there, I don't know. You know what, let's put an x there. Sorry if you're writing in pen. Okay, maybe it's like 1/2 natural log of x. Okay, this is the same thing as the natural log of x to the 1/2 power, which we can go even further with that, right? Because anything to the 1/2 power is actually the square root of x. So this kind of a transition between these worlds happens a lot in calculus, okay? Another rule that you might not remember but need to is if you have like the natural log of x plus the natural log of 2, and you're stuck somewhere in the middle of a problem, if you're adding and you have the same base, the same log base, which is e, by the way, remember little invisible e here, then you're able to put those together with multiplication, okay? And then there's one more, and that would be if you had seen subtraction there by mistake. And if you'd seen subtraction, that's actually what turns into division. So those are your 3 rules. I know you know them, but you do need to be able to go back and forth, and you're going to see a lot of practice on the worksheet that you have. Now, how is this used to help in calculus? Well, besides this that shows up all the time, you're going to have to be able to use this knowledge and these rules to get yourself out of a sticky situation. There are often times where, like, oh man, it's a lot, where we end up with a problem where we're flat out, we've done all this work and we have like 3e to the 2x equals 12, something like that. And we're trying to solve that. This happens a lot because something like this actually ends up being a type of, I'm going to write it, but you won't know what it means yet, a type of Diffie-Q parent. Now, you don't know what any of that means, but make a note of it because when it pops up again throughout the year in calculus, you can flip back to this if you need a refresher on how to get unstuck. So if you see this, then all you'd have to do is divide both sides by 3. And then to solve it out, you would need to take the natural log. You would need to rearrange and take the natural log of 4, and that equals 2x. And then you could divide both sides by 2. So you could get your answer by doing a little bit of algebra. All that I did here, guys, was rearrange. And if I wasn't clear before, if you want to go back up to the top, let's add something right up here about the relationship, because this is probably like the most important little rule here. If you have, how do we even write it? Like log base A of b, then that turns into, oh, wait, I don't like that. Okay, so my bad. If you have log base A of b equals c, that's the same thing as a to the c equals b. So you could go back and forth where you can write a log as an exponent or an exponent as a log. Now, what does that look like as a natural log? Well, it means that if you have the natural log of b is equal to c, that is the same thing as e to the c equals b. So, muy importante. Feel free to make a note of that somewhere. Okay. So that's one way. Another way that I know this shows up a lot is we'll be in the middle of a problem, and don't worry about what we've done before, but somewhere along the way in the problem in calculus, you will have something like e to the, maybe it'll look like, 1 over x minus the natural log of 3. And it'll equal something. It doesn't even matter what it equals. Okay, so if you have something like this, then a lot of people leave their answer this way. Let me put a plus here, actually, plus. And we run into this all the time. And then you're going to look at the key and you're going to be like, wait a minute, that does not match what I have. And it's because you can clean this up. Clean it up. And if you know this, when your teacher covers it next year, they're going to be like super impressed with you because everybody leaves it this way. But to clean it up, all that you have to do is use your properties of logs, okay? So remember when an exponent, when you have two things in the exponent that are being added together, that's the same thing as having e to the 1 over x times e to the natural log of 3. Do you remember that rule? So anytime two things are added as an exponent, you can split it apart. Same thing, just think backwards if that didn't make sense. If I gave you this problem, you should know, oh, you just add their exponents. So I'm undoing a common exponential rule. And once you do this, it's a good thing that you would know that the e and the natural log cancel each other out. And they cancel out and just leave the 3. So it's really 3 times all of this. Okay. Now, as I just said that and I noticed that those cancel, I noticed I made a mistake earlier on the things you need to know because I was going too fast. You know how I made a big deal about this? Natural log of 1 is 0. Well, the natural log of e is not e. It's not. Erase it. Put a big note. I'm stupid. Not you. Me. Put Miss Mink is dumb. This is not the natural log of e is e. The natural log of e is 1. I may have even said 1 and then wrote in e just because it's the end of the day. I don't know. But anyways, that should have been corrected. So you just noticed another rule. If you have e to a natural log of something, they cancel out. And you know, all these little properties are important. Okay, so hopefully this is a pretty easy week for you. I may have complicated it with a couple of mistakes I made. I do apologize, but hopefully it's clear enough that you can attempt the practice. And of course, we will have a solutions video and expand on this in tutorials. All right, good luck.